In problem 24, in this one, they give you all three sides. So A is 30, B is 35, and C is 39. And they want you to find all the pieces of information. So they want you to find A, B, and C, the angles. All right, so the first thing you do is identify the pattern of information that's provided. Three sides tells you you're using the law of cosines again. Right? When you're looking at this, for law of cosines, again, you can choose any of the angles that you want to solve first. My recommendation for law of sines is to find the smaller angles first. On law of cosines, it's the exact opposite. Look for the largest angle first. Because a cosine, there's no repeated cosine between 0 and 180 degrees. So there's no mistaking it. What I would do is I would find angle C first. So the way that you set up your law of cosines, if you don't know an angle, is you start with the side opposite that angle and plug in your value. So the side squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides, all times the cosine of your unknown angle. And now this is the case where you can't necessarily just plug it directly into your calculator. What you have to do is you have to let x be the entire trig ratio cosine of c. So I'm going to plug in an x right here so that I solve for x. Notice that's not crossing it out. That's actually just replacing it with the letter x. And I'm going to solve this. The one thing that you need to understand is if you enter it this way, what you're solving for is not the answer, it's the cosine of that answer. You're finding an actual ratio. So if I take the sum of the squares of these other two sides, subtract twice their product, and then I multiply that by x. And remember, I'm letting x represent this entire cosine of c expression. And when I solve for x here, I'm going to put it in decimal form, so I'm going to hit my green diamond button. So this tells me that the cosine of c, my x value, is this answer I got, 0.288. So if I want to find what angle c is, I need to actually take the inverse cosine of that ratio. So here, if I take the inverse cosine of this ratio, and I can either just highlight it. I could also take x, use my with key, and then highlight this whole value. That will give me my value without an x equals so that I can go back in and access that angle measure later. But that is my angle C, 73.3 degrees. Okay, once I get this angle, I can now find either of the remaining ones. You can use law of cosines again if you want, or you can use law of sines to find the remaining ones. I'm going to go ahead and use law of sines here, and I'll find the smaller of the two angles next. So I'll find angle A. So to set up the law of sines, we take the sine of the unknown angle over the side opposite it, and that's equal to the known ratio. Our known ratio is now the ratio of c's, the sine of angle we just found, 73.3 over 39. Okay, and so if I solve for this, I get my sine of A ratio. So the sine of this angle, I'll highlight the exact answer, multiply by 30, and then divide by 39. That gives me my ratio, 0.737 approximately. Therefore, the angle itself will be the inverse sine of that ratio. So if I take inverse sine, and this time I can just highlight the ratio itself, and I get my angle for A to be 47.5 approximately. And so my final step is to find angle B, is to use triangle sum and just take the total sum of the angles, 180, subtract what I have here. So subtract the 47 degree angle, go back in and subtract the 73 degree angle, and that leaves me with the last remaining one. Oops. Again, depends on, as you see on here, the decimals don't actually add up. So you may want, since you need this all to equal 180, you have the 0.5 and the 0.3 here, so you might need to enter this as a 0.2. I'm not sure what I have on there for it.